Find the normalization constant A of the wave function below and state the normalized wave function. The wave function is given to us as psi of x equal a sine 2x if the interval is from negative pi to positive pi. And the wave function is 0 if elsewhere. In actual sense, the wave function is 0 if elsewhere. It means if we integrate from 0 to negative pi and from negative pi to positive pi and from positive pi to 0. If we integrate from here to that, we are going to find a 0. The wave function will be 0 there. It can't describe any probability over there. And here too is going to give us 0. So our main focus is on this limit. The particle must be there if it exists. So that is it to know about this whole problem. Now let's start solving. So in this case, the normalization constant has already been introduced into the wave function. So there's no need for us to introduce a normalization constant again. We just have to take the absolute square of that and integrate with the given limit, negative pi to positive pi. So to normalize this wave function, we need a normalization constant, a value to multiply by the wave function, which is a here. So we are initially going to solve for a, integrating from negative pi to positive pi. So psi of x or squared, the x equal 1. And our psi of x is this term here. So this should be giving us negative pi to positive pi a sine 2x absolute squared dx equal 1. So now let's go ahead and simplify whatever is under the term here. So a to the power 2 gives us, since a is a constant, I'm going to bring it out. So let's try solving it step by step. So a to the power 2 gives us a squared, then sine 2x to the power 2 gives us sine squared 2x, and then the x equal 1. Now a is a constant, I'm going to bring it out. So a squared into bracket, integral from negative pi to positive pi sine squared 2x dx equal 1. So we are going to use the angle reduction formula in trigonometry to evaluate this. Sine squared theta is equal to 1 minus cos 2 theta over 2. So let's try simplifying this. So this sine squared now becomes, let's say, a squared integral from negative pi to positive pi minus 1 minus cos 2 theta. In this case, this is our theta, and we are going to multiply this by 2. So 2 multiplied by 2x gives us 4x, all divided by 2, the x equal 1. Since wave functions are usually in the sign and the form, this trig identity form, it is easier to keep them in memory in order to help your problem solving skills. To improve your problem solving skills. So now the next thing we want to do is to factor half out. This is the same as 1 over, this is the same as half multiplying this to get 1 over 2 here. So we can just factor half out. So a to the power 2 multiplied by half, integral from negative pi to positive pi of 1 minus cos 4x dx equal 1. So this one becomes a squared over 2 integral from negative pi to pi positive pi 1 minus cos 4x dx equal 1. So now let's integrate the term. So a squared over 2. If I'm integrating cos theta, it's going to give me sine theta. But if I'm integrating cos k theta, it's going to give me 1 over k sine k theta. So we are going to apply that idea here. So we have 1, integrating 1, a constant. If I'm integrating 2 with respect to x, it's going to give me 2x. Integrating 5 with respect to x is going to give me 5x. Integrating 1 is going to give me 1x, which is the same as x. So this place becomes x. So minus, integrating this, we have a constant here. So one of that constant, 4, we are integrating cos. Then it now becomes sine of everything here. The limit of integration is from negative pi to positive pi. So give us 1. So now we are going to put in our limit of integration, starting with the upper limit, which is positive pi. So a squared over 2. So wherever we see x, we put in pi there. Pi minus sine 4x, which is sine 4 pi. You can just divide this whole thing by 4 into bracket. Then minus bracket, we put in our lower limit, which is minus pi. Wherever we see x, we put it minus pi over there. So x, which is minus pi, minus sine 4x, which is sine 4 negative pi. So this will become negative 4 pi. All on 4, close, equal 1. So another identity that you need to know, because solving problems like this usually involve trig, sine or cos, just know the simple identities and you'll be good to go. So we know that anytime you see sine pi, it gives you 0. Sine constant plus pi gives you 0. Sine anything by pi basically gives you 0. So sine 4 pi gives you 0. So we have sine 4 pi here giving us 0. So this term becomes 0. And we have sine 4 pi here. This term becomes 0. So we are going to have a to the power 2 over 2 into bracket. This remains here pi. And what else do we have here? Negative pi giving us positive pi. So positive pi into bracket equal 1. So in this case, pi plus pi gives us 2 pi. So a squared over 2 multiplying 2 pi equal 1. 2 can take care of 2. And then we are left with a squared pi equal 1. Dividing both sides by pi, this cancel that. Then our a squared equal 1 over pi. So taking square root of both sides, our a, which is the normalization constant, going to give us square root of 1 is the same as 1, square root of pi. So this is our normalization constant. So this is what we need to multiply to the wave function that can make the wave function used to predict system. So now we were asked to find the normalization constant, which is a, and this is our normalization constant, and normalize the wave and state the normalized wave function. So the normalized wave function is now stated as psi of x equal a sine 2x, and our a now is 1 over square root of pi. So 1 over square root of pi, then sine 2x. So this is a normalized wave function. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.